An object the size of Manhattan is ripping through our solar system at a speed that defies imagination, over 130,000 miles per hour. Astronomers have named it 3I/Atlas, the third officially confirmed interstellar visitor ever recorded. But this isn't just another chunk of rock drifting in from deep space. From the very first observations, researchers noticed something unusual. Its movement showed signs of possible non-gravitational acceleration, a tiny but measurable deviation that suggested something more than the pull of the sun was guiding it. At first, the idea sounded too outrageous to consider, yet whispers began spreading among scientists. Could this enormous object actually be propelled by some kind of engine, possibly even a nuclear-powered system? The possibility is so statistically unlikely that researchers estimated the odds of its trajectory being random at less than 0.005%. If that figure is accurate, then 3I/Atlas may not be a natural visitor at all, but something deliberately engineered, a reconnaissance craft traveling across the stars. The real weight of the mystery lies in the data. The first clues didn't come from science fiction theories, but from the painstaking nightly observations of dedicated astronomers. Using observatories in Chile and Hawaii, research teams captured its position against background stars, time-stamping every frame with incredible precision. These weren't single snapshots, but thousands of data points gathered by telescopes like Pan-STARRS, the Atlas Project, and even the Hubble Space Telescope. Together, they built an ephemeris, a detailed chart predicting where the object should be hour by hour. The real test came with the residuals, the differences between where 3I/Atlas was expected to be and where it actually appeared. Even the smallest shift fractions of an arcsecond could reveal if something other than gravity was at play, if the object was being nudged by unseen forces, whether natural or artificial. The residuals would expose it as a drift or kink in its predicted path. And yet, after endless checks, calibrations, and sleepless nights of analysis, the data revealed no strong sign of propulsion. NASA's JPL and the Minor Planet Center confirmed that its orbit could be explained purely through gravity without needing to add mysterious thrust terms. In fact, every attempt to include artificial forces in the models failed to improve the fit. According to the official record, 3I/Atlas was behaving exactly as a natural body should, but science is never settled so easily. Even as the object continues on its journey, new observations are being logged every night. Each one is tested against the models again, the error bars shrinking with every new pass. For now, the evidence for an artificial propulsion system is absent, but the history of interstellar visitors has taught astronomers to expect the unexpected, because the next observation could change everything. The debate has split the scientific community into two camps. The first explains the data using classic comet physics. They argue that what we're seeing is simply sunlight warming up frozen material on the comet's surface, releasing gases in tiny jets that nudge the nucleus slightly off course. To them, even a small puff of carbon dioxide erupting into space could explain the kind of accelerations being discussed. After all, comets have been doing this for billions of years, yet the mystery refuses to go away. Spectroscopic and photometric studies so far show no clear evidence of strong jets. The coma, the cloud of gas and dust surrounding the nucleus, is visible, but its structure matches what we'd expect from solar heating, not from directed propulsion. And this is where the second camp steps in, led by theorists like Avi Loeb. Loeb suggests that the absence of obvious outgassing, combined with the sheer brightness and unusual trajectory, leaves open the door to something far more radical: a nuclear-powered spacecraft built by an advanced civilization. The theory sounds bold, almost absurd, yet it matches certain details. A nuclear reactor capable of producing gigawatts of power could theoretically drive a system that provides enough thrust to mimic the subtle acceleration observed in early data. If that's true, then 3I/Atlas isn't just a random visitor, it's a probe, carefully navigating its way through planetary flybys, perhaps on a mission of reconnaissance. Such a reactor would generate immense amounts of gamma rays, neutrons, and heat emissions that would normally be detectable by Earth-based or space-based instruments. But so far, no such excess has been spotted. Observatories like Fermi, Swift, and Neowise have scanned the object, reporting nothing unusual in the gamma, X-ray, or infrared bands. To most of the scientific community, this is compelling evidence against the nuclear engine theory. If it were true, the object should be glowing in wavelengths we simply can't miss. Still, the possibility lingers. The coma and faint tail could be hiding small jets beneath the resolution of current instruments. More precise data from the James Webb Space Telescope and the Very Large Telescope in Chile may one day resolve the question. Until then, the debate remains alive between those who trust the old, natural explanations and those willing to consider the extraordinary. For now, the mystery is sharpened by sheer scale. Photometric analysis suggests 3I/Atlas stretches nearly 20 kilometers across roughly the size of Manhattan Island. That's not just big by comet standards, it's a behemoth. Imagine a mass the size of a small city hurtling through space at 130,000 miles per hour. If it were to impact Earth, the devastation would be beyond imagination. Luckily, its trajectory shows it will pass safely through the inner solar system before continuing its eternal journey outward. But its arrival raises questions that go beyond size. Why didn't we detect it earlier? The truth is sobering. Its inbound path brought it from near the glare of the sun, a region where even our best ground-based telescopes are nearly blind. By the time surveys like Pan-STARRS and Atlas spotted it, the visitor was already deep inside the solar system. For weeks, astronomers scrambled to measure, confirm, and track its course before it slipped further from reach. The more they looked, the more unusual it seemed. Unlike Oumuamua or Borisov, the only other interstellar objects ever seen, 3I/Atlas, is massive, city-sized, and energetic. Oumuamua was barely the length of a football field, Borisov, a modest, icy mountain. But Atlas? This is in a league of its own, carrying kinetic energy on a scale we've never had to reckon with. And then comes the kicker, its orbit. Unlike planets and comets bound to the sun, 3I/Atlas follows a hyperbolic path. Its eccentricity greater than 1 proves it is not native to our solar system. It entered at nearly 137,000 miles per hour relative to the sun, a speed far beyond what gravity alone could explain. Its outbound velocity guarantees that once it slingshots around the sun, it will leave forever. This isn't a returning traveler, it's a one-time visitor, a messenger from the deep unknown, never to pass this way again. Astronomers call this V infinity, the excess velocity an object has after escaping the sun's pull. For 3I/Atlas, V infinity is about 26 kilometers per second, enough to carry it past the Oort cloud and into interstellar darkness. Its path slices through the solar system like a spear, bending slightly under the sun's gravity, but never captured, never slowed enough to linger. It's a fleeting encounter, months inside the orbit of Mars, weeks near Earth's distance from the sun, and then gone. perhaps forever. The journey of 3I/Atlas reads less like a random cosmic accident and more like a carefully mapped itinerary through the solar system. Planet after planet, its path unfolds as though plotted by a mission planner with extraordinary precision. It begins on September 30th, 2025, when the object will sweep past Mars at a distance of about 13.9 million kilometers. That may sound far, but for astronomers, it is breathtakingly close enough for orbiters around the red planet to capture high-resolution images of its coma as it sails by. Only 2 weeks later, on October 14th, 3I/Atlas makes its closest pass to Earth. At 27.5 million kilometers, it will not endanger our planet, yet this approach marks the nearest passage of any interstellar visitor in recorded history. For the first time, Earth-based telescopes will get an unprecedented look at an object that began its journey in another star system. The sequence doesn't stop there. On November 2nd, Venus becomes the next destination as the object brushes past at just 27.2 million kilometers. Then comes the grand finale. On March 8th, 2026, 3I/Atlas will reach Jupiter, gliding within 22.4 million kilometers of the giant planet's swirling atmosphere. Each event is not only charted to the kilometer, but down to days and hours, a set of fleeting windows that humanity will never see again. What makes this itinerary so suspicious is its geometry. The orbit is hyperbolic, not bound to the sun, and it slices through the solar system in a retrograde direction, the opposite of most planets and comets. Analysts note how perfectly the flybys line up, as though the object threads a narrow cosmic corridor. Simulation studies put the chance of such a trajectory occurring randomly at less than 0.005%. That number has fueled both scientific fascination and public speculation. For planetary scientists, each encounter is a gift. Mars orbiters will watch for dust outbursts. Earth-based arrays will map the coma's evolution. Venus's close pass offers infrared challenges, while Jupiter's massive gravity provides one last chance to measure how the object bends space-time as it escapes. Each flyby is a natural experiment data that will never repeat, but others see more than coincidence. The sequence Mars, Earth, Venus, Jupiter is not only rare but geometrically efficient. Each approach happens at a distance close enough for optimal viewing angles, but always just beyond the threshold of gravitational capture. Even more suspicious is the lighting. When Atlas passes Mars, the planet will be perfectly illuminated. When it brushes Earth, our planet's orientation ensures a near side view. Venus's reflective clouds will offer maximum contrast for remote sensors, and Jupiter's storms will be in full display when the object sweeps by. To some, this doesn't look random at all. It looks like a survey mission. Astrophysicist Avi Loeb has been one of the loudest voices pointing out this choreography. He argues that if a probe were designed to reconnoiter a planetary system, its path would be optimized for maximum data collection with minimum risk of detection. The alignments of 3I/Atlas, he claims, fit that description eerily well. According to Monte Carlo simulations, the probability of such a sequence happening by pure chance is less than 1 in 20,000. Skeptics disagree. They counter that the solar system is a busy place, and with billions of comets and asteroids passing through, even rare alignments will eventually occur. To them, the pattern is just a statistical outlier, a cosmic dice roll that happened to land in an extraordinary way. And yet, the comparisons with earlier interstellar visitors are difficult to ignore. In 2017, Oumuamua passed through elongated, tumbling, and accelerating in ways that sparked years of debate. But it was small, just a few hundred meters long. Now, less than a decade later, 3I/Atlas arrives, a colossal 20-kilometer-wide object threading a trajectory through 4 major planets. The timing feels uncanny. Was Oumuamua the scout and Atlas the more advanced probe? This possibility ties directly into the dark forest hypothesis, the unsettling theory that civilizations remain silent in the universe out of fear. In such a scenario, probes would not announce themselves. They would pass quietly, collecting data, and then vanish into the void, leaving behind nothing but questions. Could 3I/Atlas be exactly that, an observer that wants to look without being noticed? Adding to the intrigue are its chemical fingerprints. When astronomers measured its coma, they found an unusual composition, rich in carbon dioxide, with very little water. This ratio is reversed from what we see in most solar system comets. It suggests that Atlas may have formed in a far colder, more distant environment where CO₂ ice could remain stable for billions of years. Some argue this is evidence of its alien origin. Others say it is simply a reminder of how diverse planetary systems can be. Even the brightness adds to the mystery. Photometric models show Atlas is brighter than most comets at similar distances, though not outside natural bounds. Still, the reflectivity its albedo remains uncertain, partly because it's cloaked in dust. Some suspect it could be an engineered reflector, though no evidence has confirmed that. And then comes the question of what humanity should do about it. Within days of its discovery, mission designers at NASA and ESA dusted off old Project Lyra studies plans to chase interstellar objects. But the numbers are unforgiving. With Atlas moving at over 130,000 miles per hour, 61 kilometers per second, no existing rocket can intercept it directly. The only possibility is a solar slingshot maneuver, diving a probe near the sun and firing engines at the closest point to multiply thrust. It's risky, experimental, and the window is vanishing fast. By early 2026, Atlas will be too far and too fast for any mission to catch. This urgency splits the community. Some argue humanity must try, even with a CubeSat-sized probe, just to show we can. Others caution silence, invoking the dark forest logic. If it is truly artificial, reaching out could draw unwanted attention. So, the debate rages on. Is 3I/Atlas a natural wanderer or a deliberate visitor? Is its trajectory an extraordinary accident or a reconnaissance tour optimized for observation? As of now, no one has the final answer. What is certain is that this is one of the most improbable interstellar paths ever recorded, a cosmic event that forces us to question whether we are alone or already being watched.